Wonderful. Yeah, thank you for the introduction. So, Adrian, Boeing, the Automation Manager for Epiroc Australia. So, if we sort of look at the challenges we have in the mining industry today, you look at any mine site, you see this large, unstructured environment. It's basically a construction site that's constantly evolving and changing. As a result, it's very transient of what you're doing in one place to the next place, so things are always sort of moving around. You have different bits of weird and wonderful equipment that need to come together to try and meet your business objective of moving bits from A to B. And there's a huge amount of variability. We have this uncertainty about the ore body, so we don't know exactly what we're doing. We're discovering it as we go. So there's always going to be this variability in our operations until we have perfect knowledge of the system. And so, that sort of feeds into what are you seeing on the equipment. You're not getting this high level of operational overall equipment efficiency out of the equipment. There's also gaps in terms of where we are today and where the best practice is. So, what can we do about managing this overall mine, and what tools do we have in our basket to try and improve some of these situations? So, state of the art at the moment is, I guess, autonomy. So we'll pull that tool out of our box and let's give that a whack and see how we can try and improve the situation. So this is a case study here with BHP. So we've got 6 sites in operation in the Pilbara. 5 of those are brownfield sites. 1 is a greenfield, so that's South Flank. It's new, so they just came out straight into autonomy. But the rest of the sites went through a transition from existing manned to being retrofit to autonomous. And it's all being operated out of the central facility in Perth, 1,500 kilometres away. So what does it look like on site? So a few things to look at in this video. So first of all, it's a little bit sped up. So if you look at the top left, you can see the time, and it was done back in 2014. So it's been around for a fair while now. But if you look at the actual pattern, you'll notice it's all very nice and flat. And that's because the drills are drilling to the correct level. So from the previous bench to the next bench becomes nice and flat. Each hole location is in the correct XY spot. It's pinpoint accurate from where the drills are going. And you notice that each hole collar looks the same because they're drilling through to a quality target, so you're getting the same quality result at each time. In other words, it basically looks like a robot's drilled out that pattern. You'll also notice the machine's moving nice and smoothly. It's moved and operated in the way it's designed and intended to be operated. So what that means is, all right, we get a production rate increase. So 16% faster per hole because we're getting faster instant pen rate, but also the overall drill cycle is faster. We get a big uplift in utilisation because we've moved some of that human element in terms of shift changes, other breaks, but also now we can operate through weather conditions. So if there's a cyclone or if there's a blast in the area, you continue to operate. That extra availability gain you get through not having operator damage and operating the machine as intended. So overall, you get this 1/3 increased capacity from the drilling operations. So that lets you do more with less. So it's a good first step, right? It's a good quick win, good first step getting you along to lifting the entire process. But really where you see the major gains is when you look at something like this. So this is a real data graph of what the productive output was from a mine site. So you can see when it was manned, so the production was sort of up and down a little bit all over the place, and it's varied depending on what the particular mood of the operators happen to be and also what the weather conditions are and so on and so forth. As you transition through into autonomy, you can see the productivity drops down a bit because we're taking the machines out of production to go and retrofit them, and then it gets lifted back up to a high level with autonomy. But the really important thing here is you get this nice consistent result. And the reason for that consistent result, again, we've got a robot that's doing its work, and it can only do its work if everybody else in the previous downstream chain was doing their job correctly. So if the planning team's doing the things correctly, the development team's doing things correctly, now you've got this nice smooth process, and you get a nice smooth consistent outcome that you can control. So that takes us to state of the art today. Well, what's the next step? Because there's still a gain to be had. How do we now bring this improvement across all of the mine? So here you've got a typical vision for a mine site, looking at zero entry, no more people on the ground, fully autonomous, fully integrated mine. And why are they chasing that? Well, now you can eliminate that variability across every piece of the silo, bring these different silos and isolated islands of automation together, and you can start to design new mines. With autonomy included, you can look at a different type of mine design. I think we saw that in the keynote at the start of this conference. So if we're going down this path to have this fully integrated and optimised autonomous mine, how do we get there? Well, autonomy is the platform. To get there, we need to have good data on how we're operating today. And to get good, reliable data, you can't rely on people filling in plod sheets, with 15-minute increments and making mistakes. An autonomous system gives you the actual true data of how things are operating. It gives you a nice, rich, reliable data platform. The second thing, as you've seen, is guaranteed compliance to plan. So the autonomous system will do exactly what it's told to do. It can do it in real time and it can do it instantaneously. So it gives you that platform to do that. And it enables the new mine designs. It doesn't make any sense to build a future mine around manned and old mining methods. Future of mining is going to be autonomy, and that's what you want to optimize against. It doesn't make sense to build a faster horse and design a city around a horse that's a bunch of horses running through it, creating manure on the streets, right? You design across what is the actual end state going to be. So the step to get you to a fully integrated, highly optimized mine, first step is autonomy. So the next step, of course, is taking all those bits across to the value chain and integrating together. And I think it's fairly clear that there's lots of value to be had in integrating that mine. You'll see that as a common vision. But the real question then is why does it need to be interoperable? So if we get an integrated system, we can take ourselves from this sort of function-based, drill a hole, to the process-based, tram, level, drill, level, tram, we've got that down. But the next step really is to take it to a goal. All right, I've got a schedule, I want that executed, I want the entire pattern sorted out, go and sort it out for me. That's what the integrated system can deliver. But why do we need it to be interoperable? Well, simply, we want that agility. There's a big value statement. We've seen value statements over $500 million there. You don't want to be sit there waiting for individual pieces to come together from one sole supplier. If you have an interoperable system, you have that flexibility. You can bring those different parts together, and as well, you can choose and put together the best of breed. So you can get the best of all the worlds, leverage the innovation, the best of innovation in each individual supplier, and bring it together to give you the best system. And on top of that, to do this optimization, you need information standards. That's not data standards, it's information. You need to understand semantics. To have an interoperable system, each bit of system needs to talk to each other in a way they can understand. So you need that semantic knowledge. And that's what an interoperable system will give to you. So it's fairly clear what are the technical requirements here. We need to find a way to do this safely. It's really important that we do this safely. That's one of the key business objectives. And we need a framework to put these different bits together. But we also need to change the way we do business because, all right, now we're moving to a goal-based technical system. It doesn't make sense if we now try and still do business on a transactional nature. We now have to move to a goal-based business system as well. And if we can do that, as we've seen in some of the previous examples, and as you've seen when you do your studies about what the future of a mine will look like, you can get that increased productivity, you get that reduced cost, but now you're more agile, you're more flexible. So when you move to saying, the future of my mine will look like this, you can marry that up with what does today's mine look like, what today's equipment looks like, and bring those two worlds together and do it faster than you could before. So what's Epiroc's track record in terms of interoperability? We've been a big push on ARIDIS. It's the most successful interoperability standard that's in the mine today. We've adopted collision avoidance standards already. We integrate our system into other fleet management systems, so you can go and put a Wenco, a Hexagon, or some other system onto our drills, and they'll go and talk to each other. In terms of planning system, you can get a schedule out of Deswick imported through. You can get the drill and blast results and put them through into Maptech, and I'll use that to optimize your blasting. So a lot of people are talking about it. We've kind of had a history in it, and we're doing it, and it's been done already today. And another example of that is our integrated operations system. So we have this, what we call the control tower. It's an example system for us. We can come through, try different things, demonstrate how it works, bringing those different parts of the chain together into one test organisation. And on the autonomy piece, we can see that we're clearly leading in the space there on the blast hole drills. But we've done that function autonomy. We've ticked that box on the process autonomy, and we're well on our way to achieving that goal-orientated autonomy as well, bringing in all those different bits of asset together into the mine to one cohesive system. And how are we doing this? We're doing this through partnerships. We're leveraging innovation at the best places. So for example, we're working with Saab. They've got a good understanding of critical infrastructure, building systems that need to work. Airports can't shut down. They need to get things coming through. They have a great understanding of cybersecurity, making sure that everything is going to continue to operate in in a sort of a defence environment. ASI is another example. So yes, they have that same sort of defence and security background, but they also operate in more consumer-friendly spaces. So things like the automotive industry, agriculture, and household cleaning products. And so what that does is lets us leverage some of that innovation. You know, currently if you're looking at an autonomous piece of equipment, it's an expensive proposition. It's not the same sort of value proposition that you might want to do when you're going buying a household vacuum cleaner. You're probably not going to pay the kind of money you'd pay for an autonomous piece of kit on a mine. So by leveraging some of the innovation and knowledge from there, we can bring down the cost to mining. So that as well allows each vertical to focus on their strength, bring all that information together, and it lets us bring a true interoperable system. So it's not an assimilation of systems into one big end of systems integration piece. It's bringing the best bits from different areas together into an operable framework. So a bit of a more concrete example of how you can achieve that agility and that flexibility through interoperability is through the ASI offering and partnership we have. So up the top there demonstrates the traffic management system. So there's no need to take existing traffic management system or your fleet management system, throw it in the bin. It can be complemented through an autonomous traffic management system. And we can integrate to existing third-party systems. So what does that do? If we think back to our problem state there of this transient and variable mining environment, well, now we have this flexible system. We can go and adapt to what your current brownfields and what your future greenfields vision looks like and bring that transition across. We can start to integrate together and give you a real-time response to changing mining conditions. From the autonomous vehicles, there's some vehicles you can go out there and purchase direct from an OEM, but the goal here is to have a 100% autonomous mine. That really gets you do the step change, which means there's always going to be a few bits left over. So to address those, we have a retrofittable kit. You can come through and attach to, whether it's a bit of a hydraulically operated machine or if it's a drive-by-wire machine, and get you that 100% footprint. So again, thinking back to our problem statement, we have these large mines, these diverse mines that are going to get more diverse in terms of equipment when we're doing precise mining in the future. We can enable to get that autonomy footprint, do it safely with having these bits working together, and enable that 100% footprint, which enables that step change to a fully autonomous, unmanned mine. Thank you very much. If you've got any questions, head over to the booth because I think I've used up my time. Thanks very much.